All right, so this is 16.3, day 3. We're going to do a lot of practicing using our unit circle and making sure we have all the values that we need. A lot of this is just being able to identify, again, those two questions. Where am I? Like what quadrant am I in? So I know what the sign of my answer. And then my reference angle. So which triangle is it? Is it a 30, 60, 90 or a 45, 45, 90? So I'm going to do a couple in each section from the sheet, and then you're going to be finishing off the rest. So we'll be doing a couple in each section here just to be sure you're okay. All right, so it says find the exact information. That means you're looking for the ratio for that particular angle. So again, we're going to be asking ourselves kind of two questions here. We're going to be looking for what is the quadrant, and then what is the reference angle. So the quadrant, again, is the sign. What is it going to be, positive or negative? And the reference angle is helping us figure out what ratio it is. In other words, what triangle is it? Is this the 30, the 60, 90, or is it the 45, 45, 90? And then keeping in mind, if we have reciprocals, remember we have to flip. All right, so we're just going to kind of pick out a few of these so we can talk about what we might need to for each of them. I'm going to go to number 2. So it says sine of negative 5 pi over 4. So I want to just remind you again of what a negative angle means. Negative means we're rotating clockwise. So we're going around 5 pi over 4, but in the clockwise direction. So I'm going to go ahead to my to a picture of my unit circle here. So we have that, and you have that one of yours as well. So if we're going to do clockwise 5 pi over 4, we have to think about what that means. So positive 5 pi over 4 would put you right here in quadrant 3. That's positive 5 pi over 4. So that's halfway around and another 45 degrees. It's the same as 225. But I want to do negative 5 pi over 4 or negative 225. So that's going to put me in a different quadrant. So negative 5 pi over 4 or 225 would be 180 and another 45. That's going to put you right here in quadrant 2. So just be really careful. Sometimes it's helpful to actually draw the picture so you know what's happening. So that's a quadrant 2 angle measurement. So we're in quadrant 2. All right, the other thing to think about is what's my reference angle. This is pi over 4. So that means it's going to have the same answer as sine of pi over 4, but we're in quadrant 2, so we just have to double check and make sure we know what that means for the sign, the positive, negative. All right, so we need to know our quadrant 1 here. So sine of pi over 4 is 45 degrees, same question. That's looking for what is the ratio, the y value at pi over 4. So I'm going to think about my quadrant 1, my sine values right there. We got root 2 over 2. They're both the same. When I'm in quadrant 2, though, just double check, it's still going to be positive because it's the y. So it's the same triangle, same answer. So this is going to be square root of 2 over 2 because it's a 45, 45, 90. In quadrant 2, it's going to be positive because it's the y value. So the answer is going to be exactly the same, root 2 over 2. So when I'm thinking about what I'm looking for, I have my reference angle that told me it was root 2 over 2. My quadrant was 2, so I knew it was positive, and I can find that answer. So that's the kind of thing you're going to be doing for each one of these. Where am I? What's my reference angle? All right, let's try a reciprocal one. So we're going to try to do a couple of each type of thing here. So cosecant, CSE. So which one is that a reciprocal for? Look back in your notes from yesterday. CSE, cosecant. That is the reciprocal for sine. So here's what I'm going to be thinking. I'm going to figure out what the sine of 5 pi over 3 is, get my answer. What is that ratio? Whatever that ratio is, I'm going to do its reciprocal to figure out what cosecant is. So it's kind of a two-step kind of process here. So let's start with sine of 5 pi over 3. So quadrant, and then what's my reference angle? So my quadrant, 5 pi over 3. So let's think about what that is. So I'm going to go back to my circle here. So 5 pi over 3 is looking at all the way to like 300 degrees. So I'm right here. This is the one they're talking about. So 5 pi over 3 or 300. So where am I? I'm in quadrant 4. Okay, why do I care? Well, if I'm in quadrant 4, what do I know about sines in quadrant 4? They're the y's. That means they're going to be negative. So my answer right away is going to be negative because I know I'm in quadrant 4. Reference angle. The nice thing about radians, it's right here for you, pi over 3. So pi over 3, what is that the same as in degrees? If you need to peek back, think 180 every time you think pi. So 180 divided by 3 is the same as 60 degrees. So I need to know what is the sine of pi over 3. My answer for 5 pi over 3 is going to be the same. It's just going to be negative because it's in quadrant 4. So let's peek. 60 degrees, pi over 3 sine. There we have it, root 3 over 2. So at 5 pi over 3, notice it's the same answer, but it's just negative because we're down in quadrant 4. So this is going to be negative root 3 over 2 for my sine of 5 pi over 3, because sine of just regular pi over 3 gave me that ratio of root 3 over 2. All right, so if this was just sine of 5 pi over 3, I'm done. That's my ratio. It's a lot of just kind of reading off of these unit circles. We're going to try to really memorize that quadrant 1, because if we know quadrant 1, if I know these, it makes doing everything else so much easier. But until we get better, we can use that as a kind of as a backup if we need to look at that unit circle. But my final answer needs to be what cosecant is. That means I need to do the reciprocal of my ratio for sine. So it's still going to be negative, but now it's going to be flipped. So 2 over root 3. Now, none of those answers match, but that's because we haven't rationalized it yet. So I would multiply top and bottom by root 3. So that would give me what? A negative 2 root 3 over 3, which sure looks like that answer D there. So we can see what's happening with that. All right, let's do a cotangent. I want to make sure we do at least one tangent, cotangent, so we've hit some of the different functions. So let's do cotangent of pi. So let's think about where that is. We can think of our location. Pi actually isn't in a quadrant at all. It's right on the x-axis. So my location that we're talking about is right there. So sometimes you actually aren't in a quadrant. You're just at the x-axis. So my location is the x-axis. That means my reference angle, my distance from the x, is the same as what it is at 0 degrees. It would be the same answer. So let's think about what function I need to do then. So I know where I am. To figure out reference angle and function, I got to think about, well, cotangent. What is that the reciprocal for? Well, that's the reciprocal for tangent. So I'm going to figure out what the tangent of pi is and take whatever ratio that is and flip it. All right, so when I'm over here at pi, so I'm going to get back to my picture here. Remember what tangent is. Those are the numbers on the outside. Think slope. When I'm at tangent, that is the y over the x, or the 0 over the negative 1. Well, 0 divided by anything, that's just 0. So tangent would be 0. Now, when you think about why it's 0, it's slope again, right? So horizontal line, yep, the slope is 0. Now, here's the interesting thing, though. We wanted cotangent, right? So it needs to be the reciprocal of whatever tangent was. Well, tangent was 0 over negative 1. In other words, the 0 was on top. What happens when you flip? Well, the 0 is going to end up on the bottom. Can you divide by 0 and get a real number answer? No. So that means that your cotangent answer is going to be the undefined. So it is really important for those ones that are on the x or y axis that we really think about what happens when we flip. So tangent was 0 over negative 1. So that means cotangent, again, is going to be negative 1 over 0, which is most definitely undefined. So when we think about what's happening there, there's no number that's going to make that true. So it's all about, hey, where are you? And then being able to find the ratio. All right, so let's take a look at the sort of the next format of question like we did on our day 2 notes. We're looking at kind of going in the reverse order. So if I give you where you are and what the ratio should be, can you give me the angle? See, what we were just doing was the other direction. I was giving you the angle. I wanted you to tell me the ratio. So they want you to find the exact value of the angle measurement that gives you the ratio that they're telling you. So let's see if we can take a peek and decide what's happening there. So what they're asking you for is to find S. So you're looking for the angle measurement that makes tangent equal to 1 in this quadrant. So again, we're going back to kind of thinking about that location, those pictures. If you want to use the notes from yesterday with header or your Smarty circle that has the radian measures on it, that's really helpful to think about as we look at that. So I'm going to go ahead and just kind of replicate that picture down here at the bottom, I think. It might be the easiest. So I'm going to take my unit circle. It's not that bad, I guess. And we're going to think about what quadrant that is. So pi to 3 pi over 2. So pi to 3 pi over 2 on my unit circle. So just so I have something to draw on, I'm talking about this quadrant right here. So I'm in quadrant 3. So you should be looking on your unit circle in quadrant 3. When is tangent equal to 1 in quadrant 3? All right, well, let's take a peek at our unit circle. So I'm looking at quadrant 3 down here, when would tangent be 1? Now you have your complete unit circle with your numbers on the outside as well. So when is that going to happen? Well, it's going to happen when x and y are equal. Tangent would be a positive 1. So we're looking at this angle right here, 5 pi over 4. And notice we want the radian answer again because this angle measurement that they gave me is in radians. So they want the radian angle that goes with that. So the angle S should be 5 pi over 4. So we're just working backwards, right? We're trying to figure out, hey, if I give you the ratio, can you tell me what angle that is? So you have a couple more of those to try on the top of the back. All right, next sort of phase, I'm going to skip around a little bit because I want to talk about the things that we've already done. So I'm going to go down to number 16, kind of to the end here. We're going to talk about some of these, and then I'll go back up and finish up with the last one. So we've already talked about this in day 2. What answer or what kind of answer would you get? Would it be positive or negative? And there's a couple different looks to be able to do that. So first one is just giving you a function and telling you a quadrant. So I'm not going to do number 16 because I think that one you're going to be able to do, but let's take a look at 17. The sine function in quadrant 4. So the first thing to be identifying, you can just look at your unit circle, or you can look at the one down at the bottom. You're going to be filling in some information on that. But in quadrant 4, so we're talking about down here, what do we know about sine values? Well, sine the x or the y? It's the y. It's the second coordinate. So I know that they're going to be negative. So if sine in quadrant 4, it's going to be a negative answer. That's all they're looking at for the first ones. And remember, anything that's a reciprocal has the same sign as the original. Now, the other ones, though, like down at number 22, this is where we had to think about the radian measure. So here's where you want to pull out your Smarty circle again, or you can pull out your notes from yesterday. Just look at the look at your picture, your radian picture that we did from yesterday, so we can think about where would this put us? Like what quadrant would that be in, so we know if it's going to be positive or negative. So that Smarty circle that we did, 1 arc put us about here. That was 1 radian. 2 arcs put us about there. And then 3 arcs, remember, almost all the way halfway around, and we got to our pi, our 3.14, and then the circle continues. So we're looking at 2.9. Well, that's a little less than 3, so we're somewhere in, if I was going to draw this angle, a little bit before 3, right? So what quadrant are you in? Well, you're in quadrant 2. All right, well, why do I care? Well, if I'm in quadrant 2, that's how I'm going to be able to tell if my answer is positive or negative. So what do you know about sines in quadrant 2? Well, think about your ordered pairs. We go left and then we go up. So negative, positive. So sine is the y, always the second, so this is going to be a positive answer. So again, you're not actually figuring out like what it is. We're just trying to determine, hey, is this a plus thing or is this a minus thing? It's all about where are you and graphing ordered pairs, which you do super well. All right, so let's go up to these last couple. So this last section here, you're going to be doing something just kind of an extension of what we've already talked about. What happens if you have an angle measurement that's more than 1 rotation? So I'll give you a number example in degrees. It might be easier to visualize. So what if you're doing like 900 degrees? And you're trying to figure out sine, cosine, tangent, whatever. Well, it's really hard to know where are you, like what quadrant, when you've gone around the circle more than once. So what we're going to do is we're going to find an angle that ends in the same location. That we call those co-terminal angles. They end in the same spot. So they're going to have the same triangle. Everything's going to be the same, but it might be an easier thing for us to recognize. Well, when we do that in degrees, we just do a complete revolution and we start subtracting 360, and we do that as many times as we need to get down to an angle measurement that makes sense. So if I was doing 900, then I would be really the same as 180 degrees. If I just keep going around the circle back, well, I know where 180 degrees is and I can do everything I need to there. So that's sort of the same concept, but you can do that in radians as well. We can go all the way around the circle, talk about something that's ending in the same location, so a coterminal angle, but it's something that I recognize or I can actually see in that original unit circle. So the only difference is I'm not going to be using 360, I'm going to be using 2 pi, because 2 pi is once around that circle in radians. All right, so we need to figure out sort of our equivalencies so we know what once around the circle is for pi over 2, pi over 3, pi over 4, Pi over 6, like how many of those do I need to get all the way around the circle? Pieces of a pie. If you go back to that very first day when we did our quarter lines and our 1/6 lines, we talked about how many slices that we would need to be able to get around that circle. So I'm going to go back to a kind of a cleaner picture here. Let's do the pi over 2 first. How many pi over 2s do I need to make a complete circle? So remember, here's pi over 2, right? So there'd be 1, 2, 3, 4 of them. So to get all the way around to 2 pi, I would need 4 of those. So that would be the same as 4 pi over 2. Now, again, when you reduce that down, it should be the same as 2 pi, but I need 4 of them, right? To go all the way around the circle, I need 4. Okay, how many pi over 3s do I need? That's the next one. So let's go back to our picture here. Sometimes I think it's nice to kind of start fresh. Pi over 3 was this one right here. So this is 60 degrees or pi over 3. So that was 1 pi over 3, 2 pi over 3, 3 pi over 3. So I'll just count them out for you here. 4 pi over 3. Just looking on your unit circle. 5 pi over 3. All the way around would be 6 pi over 3, or the same as 2 pi. So for my equivalency here, for thinking about how am I going to convert, I need 6 of those guys. I'm hoping you're seeing a pattern. Whatever your denominator is, the top is always going to be double, right? Because you need 3 to get halfway around, so you need 6 to get all the way around. All right, so think about the next one then, pi over 4s. How many do you think you're going to need to make? Well, you need 4 to get all the way around, so my guess would be 8 pi over 4, right? Because 8 divided by 4 is 2. Let's just double check on our picture and see if that's reasonable. Let's do pi over 4. So pi over 4 is here. So 1 pi over 4. This would be 2 pi over 4, 3 pi over 4, 4 pi over 4. This is exactly the same counting we did on day 1 here. And then we've got 5 pi over 4, 6 pi over 4, 7 pi over 4. Just double check on your unit circle here. All the way around, sure enough, 8 pi over 4 is the same as 1 complete rotation. So that's 8 pi over 4. All right, so our last one, how many pi over 6s? Oh gosh, we're going to need a whole bunch. Double the bottom there. That would be 12 pi over 6. Again, 12 divided by 6 is 2 pi. So we'll count on our picture just to kind of prove it here. So we've got 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. That's the same as pi. There's your 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. Notice that's your same spot there. Sure enough, 12 pi over 6s to get all the way around. That's the same as 2 pi. So if we know what a rotation is, like it's way easier in degrees, right? We know it's always, we're doing 360, it's easy. The 2 pi, when we're talking in fraction numbers, sometimes can be a little bit tricky. All right, so we're going to go ahead and do one of these. The other ones are going to be the same, so I'll just kind of model it with one. All right, so 14 pi over 3. So how did I know that was more than one rotation? If you look at the biggest number you see on here in terms of pi over 3s, the biggest one I'm seeing is a 5 pi over 3. So I know I went around the circle more than once because it's bigger than 5 pi over 3. So I want to find out where 14 pi over 3 ends up. What is that coterminal with? Where does it end in the same spot? So the first thing I need to do is figure out where 14 pi over 3 ends up. So I'm going to start doing what I did over here in degrees, but I'm going to do it in radians. So I'm using a pi over 3. So what's one complete cycle? So I'm going to be subtracting that 2 pi. I'm going to subtract off a revolution, see if that gets me to a number I recognize. Well, that means I need to get a common denominator. I just want to show you the process and why this works so great. I want to have a common denominator to subtract. So wouldn't you multiply by 3? Well, that's going to give you that 6 pi over 3. It's kind of like, yep, I'm kind of doing that work for you already. So you're going to do 14 pi over 3 minus 6 pi over 3 and see if we get to some place we recognize. 14 minus 6, that would be 8 pi over 3. Well, I think we're still too far around because the biggest number I see again is 5 pi over 3. That's still more than once around. So this actually went around the circle twice. 2 revolutions passed, just like our 900 did. So that means I'm going to have to subtract again. Start with my 8 pi over 3, subtract another 2 pi, right? Another 2 pi, another complete revolution. But again, what's 2 pi? Well, that's 6 pi over 3. So I'm going to subtract another one. All right, what does that get me to? Well, 8 minus 6, that's 2 pi over 3. Okay, now, okay, I think I know where 2 pi over 3 is. So that means 14 pi over 3 ends in the same location as 2 pi over 3. Let's see if we can find 2 pi over 3. That looks like it's right here in quadrant 2. Okay, so what is the angle that they just talked about? If you're going to graph 14 pi over 3, we had to go around twice. So it's all the way around once, that was 2 pi. All the way around again, that was 4 pi. And then another 2 pi over 3 to get you to here. So that's actually what angle that was. It's 2 complete revolutions and then 2 pi over 3 more. Well, now here's the great thing. Now I know where I am, right? I'm in quadrant 2. So I had to figure out where, oopsies, where that angle was. So for number 12 here, I now know that I'm in quadrant 2, because it's the same as 2 pi over 3. It's coterminal with 2 pi over 3. So my answer is going to be the same as what it is for cosine of 2 pi over 3. It's going to be the same ratio, same sign, everything is what that angle is, because they end in the same spot. It's going to be the same triangle. So if I'm in quadrant 2, what do I know about cosines? Well, I know that they're negative, and the ratio is the same as what it is at 60, which is a half, but it's negative because it's in quadrant 2. So my final here is going to be negative 1/2. Because it's the same location as cosine of 2 pi over 3, which is going to give me negative answer because it's cosine in quadrant 2, and it's going to give me the 1/2 ratio because it's pi over 3. So it's a little bit extra work, right, to figure out where am I, because it's not so obvious. You have to find an angle that ends in the same spot. So when you go on to do number 13 and you're doing 13 pi over 4, you're going to want to use 8 pi over 4 when you're subtracting to get a coterminal, subtracting off your 2 pi, because you want to have something that has the same denominator. You want to be counting the same number of slices. When you do number 14 pi over 6, you're going to want to be using the 12 pi over 6. So it's a nice way to be able to solve for those. So you have the kind of the other pieces to fill in. Day 4, we're going to be doing very similar. We just have to get a lot of practice in so we get comfortable on our unit circle.